Okay, while people are streaming in, let's get started. Warm welcome to everyone. And today we are live streaming from New York. Are you in New York, Barbara?
Yes, I am.
Yes. And a very warm welcome to you, Barbara.
Thank you.
And the usual housekeeping comments. This is being recorded and will be uploaded later on. If you have a question, please feel free to ask it. I request, please do not put it in the chat box. Please put it in the Q&A box. It's easier for us to sort through them. And with no further ado, Sandy, over to you to introduce Barbara and our lectures.
Thank you very much, Padma, and welcome everyone to the Linnean Society of London. It's great that we can have these virtual lectures and have people come and speak to us who perhaps might not have been able to come otherwise because of very full schedules. And I just want to kind of outline a little bit about what the Linnean Society is about, because I'm not sure that everyone who's watching is a fellow. The Linnean Society is the oldest biological society in the world that's still extant. And what we are about is about valuing nature in all of its forms and studying nature in all of its forms. So the Linnean Society is unique in that it accepts both amateurs and professionals and people from all walks of life, all backgrounds, all ages. But the one thing that everyone who's a fellow of the Linnean Society has in common is a passion for natural history. And so if you have a passion for natural history and you're not a fellow of the Linnean Society, please do get in touch, because we welcome new fellows, and we welcome new voices and new ways of looking at things. We're embarking on a big journey of change now. And I think that the more fellows we have and the more different voices we have contributing to this journey, the better for us. So please do come and join us. It gives me great pleasure tonight to introduce Dr. Barbara Thiers, who Padma asked me before, how long have you known Barb? And I said, I really don't remember. Maybe you do, Barbara. We were probably graduate students at the same time and our paths crossed in Herbaria here and there. Barb is in charge of the New York Botanical Garden's Steere Herbarium, which is one of the largest and most active herbaria in the world, with 7.9 million specimens and a very active loans program and also an active collecting program. Barb's been a pioneer in digitizing and making available herbarium specimen data. The New York Botanical Garden, under Barb's direction, is really one of the places that started the whole idea of let's just take pictures of herbarium specimens and make them available. She's been very much at the forefront of uniting information technology with herbarium management, which has really brought a new level of professionalism to how we look after our herbaria, and also for kind of increasing the access of herbaria for multiple uses. And if you don't know what a herbarium is now, you certainly will by the time Barb is finished with her talk. She's been a great advocate for change in our community and has been really at the forefront of getting us all to think in new, different, and exciting ways. And tonight we welcome her to give us a talk about herbaria collectively saving plant and fungal diversity. And this connects with her absolutely fascinating book of the same title, which I must recommend to everyone. So I hope everyone who enjoys the talk goes out and buys the book. Thank you so much, Barb, for agreeing to talk with us tonight, and over to you.
Thank you, Sandy, for that very kind introduction. Feels like I've known you forever, but I can't remember the date, but it's been a long time. For the past almost 6 centuries, scientists have been documenting the plants and fungi of the world through herbaria. This very simple means of preserving biological tissue was a key innovation in transforming the study of plants and fungi from a minor subdiscipline of medicine into an independent scientific endeavor. The herbarium made it possible for scientists to characterize those plants that grow in faraway places and to understand their diversity on a global scale. In my talk today, I want to tell you a few stories that I especially like from the history of herbaria. I'll also talk a bit about how herbaria contribute to understanding the environmental challenges we face today. Most of the content I'll present here is from my recent book on herbaria, which Sandy just mentioned. I've been around herbaria all my life. My father was founder and curator for 40 years of the herbarium at San Francisco State University. And in addition to an unrelentingly heavy teaching load, he poured his considerable curiosity and energy into documenting the fungi primarily, but also the bryophytes and lichens of California. My childhood weekends were spent either on field trips or in the herbarium, where I could earn some pocket money by helping my dad with his specimens. Honestly, the money was far more motivating to me than any love of herbarium work. At one point, I had a specific fundraising objective in mind. In the worst way, I wanted a pair of white go-go boots, which were all the rage in the late 1960s and which my mother had refused to buy for me. And once I had my boots and I was in the thrall of teenage rebellion, I wanted nothing more to do with the herbarium, or my parents for that matter. But eventually, in the middle of my college years, I found my way back. I discovered that I too wanted to participate in the great adventure of documenting plant and fungal life, and to join my dad and his passionate, often eccentric band of students and colleagues who derived such joy from this work. I arrived at the New York Botanical Garden in 1981 to start a one-year postdoctoral fellowship in the herbarium. My project was to organize and index the collections of the William Mitten Bryophyte herbarium. Mitten was a 19th century English apothecary and self-taught botanist who obtained bryophyte specimens from essentially all of the famous European exploring expeditions. The work was thrilling but frustrating because often these historic specimens lacked adequate documentation. A scribble in terrible handwriting might be all that accompanied a historic type specimen. From that experience, frustrating as it sometimes was, I developed an enduring interest in botanical exploration and the documentation of historical specimens. It would be a while until I came to see that specimens might represent more than a plant species or a plant name in the case of types. With the benefit of a number of conscious raisings publications and the input of colleagues, I, like so many of you, have come to recognize other dimensions to these historical specimens, including the imperialist instincts and proceeds from slavery and indenture that fueled expeditions on which they were collected sometimes, and the lack of acknowledgement either of the contributions of the plant knowledge of local people who helped with collecting, or the hundreds of unknown curatorial staff members who processed the collections and have maintained them ever since. Despite the fact that some specimens were acquired through loathsome activities and credit for them has not been shared fairly, I believe herbarium practices today highlight some of our better human impulses to save things for the future, not just for ourselves, but for generations to come. Investing time and resources to care for these irreplaceable representatives of plant and fungal life and sharing them freely with anyone wanting to study them is both generous and wise. Among the many things I have loved about working in a herbarium has been the opportunity to visit and get to know the staff who work in these institutions all over the world. Working sometimes under incredibly difficult conditions and often with little appreciation, Herbaria remain committed to maintaining this vital source of knowledge about our world. Evidence suggests that this man, Luca Ghini, created the first herbarium. Ghini was from the region around Bologna, and he lived at a time when the Renaissance was starting to blossom in northern Italy. Forward-looking universities in the region encouraged independent thought, and new ideas and goods came from travelers passing through en route from northern Europe to the Mediterranean and the Middle East. After graduating from the University of Bologna with a medical degree, Ghini was hired on there as a professor. He offered what is generally believed to be the first botany course offered in the medical school with a focus on medicinal plants. Instead of relying purely on classical texts such as Dioscorides' Materia Medica, Ghini encouraged his students to make independent observations of plants that he collected for their study. Ghini's course was very popular with students, and within a few years it was elevated to a core element of the curriculum. He compiled a set of plants glued to bound pages of a book as a reference for his student. And later, he created the first botanical garden in Pisa when he moved on to teach at the university there. Like his herbarium, the aim of his garden was also to aid in the teaching of botany. Ghini's own herbarium has not survived, but those of some of his students still exist, and some are shown here. The herbarium method spread throughout Europe by botanists such as Guillaume Rondelet of Montpellier, who visited Ghini specifically to learn the technique. Rondelet's student, Leonard Rauwolf, created the most beautiful of the early herbarium volumes, his collection of specimens from Eastern Europe and Western Asia, which was owned by various kings and queens of European countries before finding its permanent home in Leiden, now at Naturalis. The border around the pages of Rauwolf's herbarium is a type of wallpaper that was used to cover wooden beams. As you know, herbaria contain not just vascular plants, but also algae, bryophytes, and fungi, including lichens. Most of the 16th century botanists largely ignored these organisms because it wasn't until the microscope was invented that their life histories could be understood. However, a few bryophytes and lichens and the occasional alga can be found among the pages of the earliest herbaria. Two early herbaria that focused on these organisms were those of Per Antonio Micheli and Johannes de Linneus. Micheli was the first to describe reproduction in fungi, and thus he's often considered the founder of the study of mycology, and is also known for his pioneering studies of bryophytes and lichens. His herbarium, which also includes that of his students, is maintained at the University of Florence and contains about 19,000 specimens. De Linneus, a German botanist hired by Oxford University, was very much influenced by Micheli. However, he relied less on microscopic features, causing him to misinterpret things like the sporophyte in mosses, which he described as flowers. His herbarium consists of about 900 specimens on 176 sheets. Whether inspired by Rauwolf or just similarly inclined, the pages of his herbarium specimens are also bordered with a type of wallpaper. At the time that Ghini was inventing the herbarium, other world cultures were building upon centuries of plant knowledge that surpassed that of Europe in volume, longevity, and continuity. Chinese scholars produced a new and original work on pharmaceutical botany at least every century, beginning in 300 before the Common Era. The unbroken advance in plant knowledge over time in China led to a consistently high level of accurate description and illustration and a standard method of naming plants. The impetus for plant knowledge in the Islamic world had a spiritual as well as a practical basis because descriptions of the paradise in the Quran included the names of plants that grow there, and because plants are invoked frequently in stories of the Creator's power. One of the earliest for which a part still exists is the Kitab al-Nabat, or Book of Plants, that describes some 600 species. Many publications of a similar nature followed this one, documenting the plants and their uses throughout the far-flung Islamic world. The Aztec king Montezuma maintained botanical and zoological gardens that were said to be far more advanced than those in Europe. Aztec libraries contained thousands of manuscripts written on paper made from the bark of the shortleaf fig. Sadly, the libraries were burned in the European conquest of these territories, destroying all records of pre-colonial scholarship. Most of what we do know about Aztec plant knowledge comes from a work often referred to as the Badianas manuscript, written by two Aztecs who had assimilated into colonial culture. Interestingly, none of these cultures developed the tradition of herbaria. Why is that? In the seasonal European climate, many plants cannot easily be observed all year long. However, in other parts of the world with a tradition of written scholarship where the climate's more moderate, plants could be observed for a longer period of years. So maybe there was just less need to use preserved material to observe plant features. Maybe more important, none of these cultures but European had a prolonged period of intellectual stagnation like the Middle Ages, which interrupted the tradition of recording natural history information that had been established by classical authors. When science reemerged in the Renaissance, European scientists lacked the knowledge base that had been accruing century by century, forcing them to start afresh to build this knowledge. And the lack of a precedent and an intellectual climate that was open to new ideas are thought to have spawned many innovations, such as the telescope, the microscope, and perhaps herbaria and natural history collections in general fall into that category as well. Beginning in the 1600s, European countries invested heavily in sea and land-based exploration, the goal of which was to establish colonial outposts where they could exploit local resources for products for trade and to secure safe and dependable routes to transport goods back home. Many of the products they were keen to obtain were plants or plant-derived, most notably spices, but also horticultural plants such as tulips, which had sold for astronomical prices in the early 1600s. The first explorer charged specifically with a collection of plant specimens for scientific purposes was William Dampier, a working-class Englishman who started his life at sea shortly after completing his primary education. Dampier made his first trip around the world as a privateer, a sort of government-sanctioned pirate. A privateer had permission to attack foreign ships during wartime and take the ship and its contents as a prize. Dampier kept a very lucid and detailed written account of his travels on this trip, not only of his plundering adventures, but also the sea currents, landforms, people, and plants and animals he encountered. He went to great lengths to maintain his journal, placing the rolls of parchment within hollow bamboo stems, the ends of which he sealed with wax. When Dampier returned to England from this trip, he was introduced to a new phenomenon that had developed in his absence, the coffee house. An interesting feature of coffee houses was they were one of the few places where the social classes mixed. Dampier frequented Jonathan's, a coffee house in Change Alley in central London. There he rubbed shoulders with powerful people who were fascinated by his stories, which prompted him to write a book about his travels. It was hugely popular and went through 3 printings and was translated into Dutch, French, and German. Support from the friends he made at the coffee house and the success of his book led the Royal Navy to sponsor a second expedition for Dampier. He was to survey Terra Australis, which included Australia, but was also thought to be a much larger landmass. The English Navy was especially interested in having him explore the eastern coast of this continent, which many thought extended all the way to the South Pole. Although enthusiasm was high for the voyage, the ship assigned to it was a little disappointing. The HMS Roebuck was a 9-year-old fire ship, one that, being near the end of its useful life, was slated to be used as a weapon. In the height of a close naval battle, the ship would be filled with combustible contents, sent into an enemy fleet, and then ignited. Dampier's expedition departed in 1699. His route took him first to Brazil, as did most expeditions to the Pacific. But instead of sailing around Cape Horn, Dampier headed east from there, sailing farther south than most other ships, taking advantage of the strong winds in the roaring 40s. About 4 months after leaving Brazil, Dampier and his crew reached the western coast of Australia, low on supplies of food and water, but without any loss of crew to scurvy or other mishaps. The first Australian landfall was on Dirk Hartog Island in Shark Bay. It was named for the first Dutch explorer to set foot there in 1616. Dampier collected about 20 flowering plant specimens and 1 marine alga on Dirk Hartog, which he pressed between the pages of a book. Although he complained that some of the specimens were spoiled, those that survived were very well preserved and perfectly adequate for scientific study. At another Australian landfall, he discovered his most spectacular flower, the plant now known as Sturt's desert pea. From Australia, the expedition sailed north to New Guinea. But as the trip progressed, Dampier became increasingly concerned about the state of his ship, whose hull was badly damaged by shipworms. He decided not to continue on to the eastern coast of Australia, his primary destination, but instead to begin the trip home. They made it most of the way back to England, but his ship sank off the coast of Ascension Island in the Atlantic. They were near enough to land that all survived the wreck, but many of Dampier's specimens were lost. The sailors were eventually rescued by a passing Royal Navy ship, which returned them to England. The surviving botanical specimens included the plants from northwestern Australia and a moss from New Guinea, but not much more. Upon return to England, the specimens were deposited in the Herbarium of Oxford University. About 17 species based on his collection were described by the botanists of the day, but the rest were forgotten. Sturt's desert pea, for one, would not be described for another century. Dampier wrote a book about his second trip as well, but it was not as popular, perhaps because it was more natural history and less swashbuckling than the first. He was dismissed from the Navy because he lost the Roebuck and because he'd had his second in command taken off the ship in chains at an early landfall. Although he made many more sea voyages as a privateer, he didn't collect any more specimens. In addition to the descriptions and illustrations of plants and animals that no one in England had ever seen before, his 2 books contain the first known written usages of more than 1,000 words, according to the Oxford English Dictionary, including such commonly used words as barbecue, avocado, chopsticks, and tortillas. At the time of Dampier's collecting trip, there were only a small number of institutional herbaria, all in Europe. The majority were held in bound volumes, and collectively they contained perhaps several 100,000 specimens. During the 18th century, specimen holdings increased greatly from all of the exploring expeditions. Linnaeus played a key role in promoting the herbarium as the central resource for the study of plant diversity. He learned herbarium techniques from his mentor and employer, George Clifford, who maintained a sizable personal collection. Clifford broke with the tradition of keeping herbaria in books and instead mounted his specimens on separate sheets of paper so that they could easily be reorganized as new specimens were added. In comparing the specimens from the Clifford Herbarium with one made today, we see that the technique is really quite similar. Hasn't changed that much. Clifford liked to add the embellishment of a paper urn at the base of his specimens, and included only a small amount of information about when and where it was collected. Today's specimens lack the pretty vase, but bear a label with detailed metadata. Linnaeus created the bespoke herbarium cabinet, a narrow wooden cabinet where the specimen sheets could be stored in a prescribed order, the precursor of the type of cabinets we use today. By the end of the 19th century, there were about 250 herbaria in Europe, held in 18 countries, providing enough documentation for botanists there to summarize the major plant groups of the world. Another 368 herbaria would be formed in the 20th and early years of the 21st century, but of the total nearly 1,100 herbaria that have existed in Europe, about 1/3 no longer exist. Many smaller herbaria were combined with larger ones, but the status of some is still unknown. Today, as best we can tell, there are 688 active herbaria in Europe with about 175 million specimens. The European tradition of herbaria has spread to almost every country around the world, following a common pattern. At first, Europeans, explorers, and immigrants make collections for study by scientists back home, but as immigrants become citizens and a national identity is formed, in-country herbarium become part of the scientific infrastructure for interpreting the history and natural resources of a new nation. Politics, traditions, and perspectives of each country give each own herbarium story a unique flavor. In Australia, the figure that looms largest among the 19th century immigrant botanists is Baron Ferdinand Jakob Heinrich von Müller, born in 1825 in Rostock, Germany. He was in training to become a physician when most of his family died from tuberculosis. Following this loss, he and his surviving sisters decided to immigrate to Australia, arriving in 1847. He began collecting plants partly out of interest in documenting a still largely unknown flora, but also for the possibility of discovering new medicines, perhaps motivated by his own family tragedy. On recommendation from William Hooker, he secured an appointment as the first government botanist in Victoria, a post he held for 43 years concurrent with other appointments, including Director of Botanic Gardens in Melbourne from 1857 to 1873. Von Müller was a prodigious collector, participating in a wide range of expeditions across the continent. Realizing that the documentation of the Australian flora was far too large a job for one person, he established a network of more than 200 plant collectors throughout Australia, many of them housewives on remote outback stations that responded to his newspaper advertisements. In exchange for specimens, he offered packets of garden seeds. Von Müller wrote as vigorously as he collected, producing 11 volumes of observations and descriptions of new species in a series called Fragmenta Phytogeographica Australiae, 2 volumes on the plants of Victoria, and treatments of large and complicated Australian genera such as eucalyptus and acacia. He wanted to write a flora of the continent, but was dissuaded by Hooker and Bentham because they didn't believe he could do a comprehensive treatment without reference to the historical collections in European herbaria. Instead, they proposed that von Müller send his entire herbarium over a period of years to Kew for examination. Because he served at the pleasure of the British government, he had no choice but to comply. Von Müller was acknowledged in the resulting publication, Flora Australiensis by Bentham, but the authorship but he was not included as an author, which was a bitter disappointment to von Müller. The German government, though, recognized his contributions to the understanding of the Australian flora by conferring the title of Baron upon him, and he is also commemorated in the names of many Australian places and plants. In Australia today, there are 34 herbaria holding approximately 8 million specimens. 80% of all specimens are held in government institutions, primarily botanical gardens. 16 herbaria are associated with universities. An important organization enabling the nationwide study of Australian plants and fungi is the Council of the Heads of Australian Herbaria, actually now Australasian Herbaria, which is formed with the goal of creating a nationwide forum for discussion of herbarium and flora-related issues. Most herbarium specimens in Australia have been digitized and are available for searching through the Atlas of Living Australia. João Barbosa Rodrigues was one of Brazil's most important early botanists. His father was a Portuguese merchant and his mother was indigenous Brazilian. Raised in Minas Gerais, he received a classical education and was also an accomplished poet and artist. He began his botanical expeditions in 1868 with trips within the states of Rio de Janeiro and Minas Gerais, extending later to northeastern Brazil. He was commissioned by the Brazilian government in 1871 to explore the Amazon basin, and he lived there with his family for several years, collecting indigenous peoples' artifacts and animals, as well as plants. In 1890, Rodrigues was offered the position of director of the Rio de Janeiro Botanical Garden. He found it in a poor state with no library or herbarium and many of the living collections unlabeled. With help from the Portuguese royal family, Rodrigues found funding to improve the garden's resources. To form the nucleus of the herbarium, he obtained that of Anton L. Fay of the University of Strasbourg, who had specialized in Brazilian ferns. From this base, Rodrigues built the herbarium at Rio into the largest in the country. While in Manaus, Rodrigues had begun work on an ambitious project of colored illustrations of living orchids prepared with the help of his wife, Constanza. The set ultimately contained 900 plates, many of which illustrated species that Rodrigues had discovered. Unable to find financing to publish the colored plates, he described some 540 new orchids without illustration in a 2-volume work and allowed Alfred Cognot to publish black and white versions of some of his illustrations in Cognot's treatment of orchids for Flora Brasiliensis. Disappointment at not being able to publish his full color orchid paintings stayed with Rodrigues the rest of his life. They were finally published posthumously in 1996. Rodrigues had better luck publishing his work on palms, but here too, the challenges of doing serious systematic work on plants outside of Europe in his time are evident. The Brazilian government helped to finance Certum Palmarum brasiliensium, which included numerous new species and 171 watercolor paintings. The impact of this work was lessened somewhat, though, through the actions of the English palm specialist James Trail, who had accompanied Rodrigues on an expedition to the Trombetas River and whom Rodrigues allowed to study his drawings and notes. Sometime after the publication of Certum Palmarum, Trail published some of the same new species with different names, relegating Rodrigues's names to synonymy. Despite this disregard for Rodrigues's work by European contemporaries, his great contributions to Brazilian botany today are well recognized. The Museum of Rio de Janeiro Botanical Garden was named for Rodrigues on the 100th anniversary of his birth, and he is eponymized by several plant genera and also in the botanical journal Rodriguesia. Today, Brazil has 190 active herbaria with a total of about 8.4 million specimens. Recent growth has been very strong. The number of herbaria and specimens has almost doubled since 2000. Herbaria are found in all states of Brazil, with the strongest concentration in the south. 68 Brazilian herbaria are associated with universities and about 16% with research institutions and 10% with botanical gardens. Digitized specimen data for more than 7 million specimens of Brazilian plants and fungi, representing the holdings from 130 Brazilian and 20 foreign herbaria, can be searched through Species Link, managed by CRIA, or the Center for Environmental Information. Species Link is one of the world's most innovative specimen data portals, offering, in addition to herbarium specimen data, a variety of tools for refining these data and for predicting species distributions. Although at first interest in botany of what would become the United States of America was largely by and for Europeans, by the time of independence, those immigrants who decided to become Americans were beginning to take an interest in developing their own scientific resources, including herbaria. A lot of that early interest was focused in Philadelphia and the surrounding countryside. Capital of the United States until 1800, Philadelphia was also the first academic center of the country, home to the American Philosophical Society, the nation's first scholarly organization, which was founded in 1743. The APS was home to the first institutional herbarium in the US, incorporating some important early private herbaria as its foundation. Many specimens originally deposited there were later transferred to the nearby Academy of Natural Sciences. The first government-organized exploration in the United States that resulted in herbarium specimens was that of Lewis and Clark, both of whom were trained to make botanical specimens by Philadelphia botanist Benjamin Smith Barton at the request of President Thomas Jefferson. They made well-documented specimens, about 220 of which survived the trip. However, these specimens were almost lost entirely. About 50 were taken to Europe by a German botanist who later donated them to a private British herbarium. When that private British herbarium, was sold at auction, 50 of the specimens were, these 50 specimens were purchased by an American botanist who just happened to be in attendance. And he, when he got back home, donated them to the Academy. For a long time, these 50 were thought to be the only surviving specimens from the Lewis and Clark expedition. However, the fate of the remainder was unknown until they were discovered almost half a century later in the attic of the American Philosophical Society. They were found still bundled in their original pressing papers, and some, sadly, had been eaten by beetles. Today, the specimens are very well cared for at the Academy in a room designed specifically for them. They're among the most frequently studied and annotated of American plant specimens, and they've all been digitized and are available online. After Lewis and Clark, the US government sent many additional expeditions throughout the 19th century to explore the Western US. But the botanical results from these were handled more efficiently than in the case of the Lewis and Clark specimens, and they mostly went to one of two prominent East Coast botanists who promptly studied the specimens and published the results. These were John Torrey, a New York City native who became really the first internationally recognized authority on American plants. His herbarium eventually formed the nucleus of the New York Botanical Garden Herbarium. Asa Gray was a student of John Torrey and took over his role as the leading American botanist. And his herbarium is the centerpiece of the Harvard University Herbaria today. As the US population moved westward, interest in documenting the local flora went along with it. St. Louis, Missouri, the frequent launching spot for westward exploration, became a major botanical center, today reflected in the herbarium of the Missouri Botanical Garden. After the gold rush created the city of San Francisco from the quiet mission town of Yerba Buena, centers for botanical study developed on the west coast of the United States at the California Academy of Sciences and at the University of California in Berkeley. The California Academy of Sciences was founded in 1853 with the mission of documenting the plants, animals, and geology of the state. The Academy had an interesting clause in its charter, indicating that the institution, quote, highly approved the aid of females in every department and earnestly invited their cooperation. It thereby became one of the first institutions in the country and possibly the world to recognize and encourage women scientists, a decision that paid off for the institution in spades due to the efforts of two highly accomplished and energetic women that it employed. Kate Brandegee, who trained as a physician at UC Berkeley, was hired as a curator of the Academy's herbarium. She and her husband Townsend collected extensively throughout the state and also in Baja California. Kate eventually gave up her job as curator to focus solely on plant collecting, and to replace her, she hired Alice Eastwood, a talented young botanist from Colorado. Eastwood was born in Toronto but moved to Denver as a young teen. Her early love of nature, especially plants, grew during long hikes in the Rockies. She was a talented student, graduating from high school as class valedictorian. However, her family's precarious financial situation precluded the possibility of higher education for her. Instead, she taught high school, but continued to spend as much time as possible exploring the plants of the Rocky Mountains on her own, and she developed a local reputation for her trail experience and plant knowledge. When Alfred Russel Wallace visited in 1887, it was the 28-year-old Eastwood who took the famous tropical explorer, then in his 60s, on a 3-day hike to the 14,000-foot summit of Gray's Peak, introducing him to Colorado's diverse and beautiful alpine flora. A lucrative real estate sale allowed Eastwood to quit her teaching job and travel, and that's where she met the Brandegees. Eastwood's energy and enthusiasm for the study of plants and her dedication to the Academy's herbarium gained worldwide appreciation through her heroic efforts to save the herbarium during the earthquake and fire in San Francisco on the morning of April 18, 1906. Eastwood felt the tremor that morning, but since it was not strong in her neighborhood, she went to work with no particular anxiety. However, when she reached the academy, she saw that the building was damaged, and worse, the surrounding buildings were on fire. The building's stairway had collapsed, but Eastwood managed to climb up the banister to the 6th floor where the herbarium was housed. She had only minutes to save what she could, so she chose the approximately 1,500 type specimens and her Zeiss hand lens or lens. She bundled the specimens in a large piece of fabric and lowered them to the ground by rope to ground level. By the time she got back downstairs, the police and firefighters were desperately trying to clear the area as the fire closed in. Eastwood secured the specimens on a horse-drawn cart and took them to safety. The academy and all of its remaining specimens were lost, as was Eastwood's own home. In a letter to Science magazine published some months later, she wrote, "It is a great loss to the scientific world and an irreplaceable loss to California. My own destroyed work I do not lament, for it was a joy to me while I did it, and I can have the same joy in starting again." When the Academy reopened its doors in 1916 in its new headquarters in Golden Gate Park, Eastwood went right to work rebuilding the collection. Under her care, the new Academy Herbarium grew from the nucleus of saved specimens and reaching a total of 300,000 by her 80th birthday. Today, there are approximately 700 active herbaria and 78 million specimens in the US. The majority of herbaria and half of all herbarium specimens are in institutions of higher learning, and indeed the history of herbarium growth closely follows the history of university of education in this country. The Morrill Act of 1862 set in motion a plan by which the states could receive a portion of the profits derived from the sale of Western land by the federal government if the states would use these profits to establish programs of agricultural, mechanical, and military study, as well as liberal arts. This led to the establishment of the so-called land-grant universities. Most of the original land-grant colleges developed herbaria between 1860 and 1920, and except for two, all still exist in their original institutions. Largely with funding from the National Science Foundation, especially during the past decade through its advancing digitization of biological collections programs, most herbaria in the US have digitized at least some portion of their holdings. Data for approximately 20 million plants and fungi occurring in the US can be searched through the iDigBio data portal. Worldwide, today there are approximately 3,300 herbaria in 176 countries. Together, they hold about 390 million specimens. Herbaria still serve their original function to document the occurrence of plants and fungi and to provide a reference for their identification and characterization. However, recent technological advances have allowed us to broaden the use of herbarium specimens. You're all very well aware that DNA can be recovered from the tissue of herbarium specimens, the process for which has been refined over time to require smaller amounts of tissue, and the success rate has increased even for very old specimens. The specimen shown here of Agalaya eleagnoides, collected in 1835, is the oldest at the New York Botanical Garden from which DNA has been extracted successfully. Now, with next generation sequencing, we're able to get more information from such extracts in order to understand which genes control plant traits and how variation in the expression of these traits have developed in different locations and in different lineages of organisms. Specimen digitization has opened up many new uses for herbarium specimens. Today, there are about 80 million digitized herbarium specimens shared through these various data portals, representing 20% of all that exist. As a result, we're now able to analyze very large sets of data from a wide range of institutions to understand current plant distributions and to predict their future. For example, this map plots the locations of herbarium specimens from Brazil, overlaying map layers that show the distribution of Amazonian forests in green and the location of fires in the summer of 2019 in red, allowing a visualization of what plant biodiversity may have been lost through that environmental catastrophe. Using plant specimen images, it is now possible to score large numbers of specimens for their phenological state, whether they're flowering, fruiting, or in bud. And through correlation with the specimen metadata, that is where it was collected and when, we can track changes in flowering and fruiting patterns over time and space. We can also assess the degree and timing of some types of insect and fungal predation from specimen images as well. There's great interest in the moment at applying machine learning techniques such as computer vision and data mining to digitized herbarium specimens. This work is at an early stage of development, but holds great promise as a technology that can build on digitized specimens to broaden their use even further. Estimates suggest that up to 50% of the still undescribed species of plants may actually already be represented in herbaria, but are either misidentified or are in the unidentified backlog that almost every herbarium holds. Preliminary attempts to apply machine learning to plant identification from herbarium specimens have shown that algorithms can match images of specimens of unknown identity to an identified reference set with an accuracy rate of between 85 and 90%. And further refinement of the process will likely make the rate of correct matching even higher, especially if we are able to combine machine learning with other types of descriptive data, for example, species distributions and morphological characteristics. Because of all the digitization and the expansion of research uses, the past decade has been a golden age for herbaria. Still, we face significant challenges at the moment, most stemming from insecurity of funding. Herbarium budgets rarely rise in good times, but they almost always fall when economic times are bad. And based on surveys of collections during this pandemic time, there is reason to be concerned about the future of some herbaria and other natural history collections. Remaining relevant is key to retaining an institutional funding base sufficient to cover the maintenance and growth of an herbarium. The collection must be relevant to the institution that houses it and to broader national and international scientific and educational goals. We need to keep collecting in order to continue the record of plant life we've built over the past 6 centuries. There have recently been calls for a more holistic approach to collecting. It's been routine for a while to capture photographs and preserve material in silica for DNA extraction later, but perhaps we should be routinely collecting a wider range of tissues as well as collections of commensal organisms and soil and microclimate data. These data could feed directly into an extended specimen network that would greatly enhance our ability to document the interdependency of organisms and understand how species loss may affect ecosystems. Such a network, combining data from existing and newly collected specimens, could greatly extend the reach of herbarium-derived data. The expanded specimen network concept originated in the US, but it parallels very closely the digital specimen concept, which has grown out of the DISCO effort in Europe. A multinational team sponsored and led by the Global Biodiversity Information Facility, or GBIF, is currently working to reconcile the minor differences between these two concepts. Since protecting biodiversity has to be an international effort, it is important that any networks developed nationally or regionally be compatible globally. Another way in which herbaria can remain relevant is through public outreach. Even though generally not open to the public, herbaria have an obligation, in my view, to help people realize the central role that plants play in our lives and to understand why protecting biodiversity is critical to our own future. At the York Botanical Garden, we have annual or twice yearly open houses. We put out a lot of specimens, each with a short accompanying story, usually oriented around a theme. Our Plants in Love theme for Valentine's Day open house was my favorite. We get plenty of staff to stand by the counters and engage with folks who pass by. We also offer a hands-on activity like flower making, and we create Instagram opportunities as well. Obviously, during pandemic time, we've not been able to engage in visitors on site, but we have used our digital platform for public outreach. Our primary method of doing this is through a feature of our virtual herbarium called the Hand Lens, which we use for telling interesting short stories about specimens or collectors or other people associated with the collection. A few of the recent stories are highlighted here. Most recently, we've been using the Hand Lens as our primary vehicle in our effort to decolonize the herbarium. That is, to highlight the accomplishments and contributions of botanists from developing countries or from groups not traditionally well represented in science in the US. Keeping herbaria supported for future generations will not be easy. But a study of the history of herbaria reveals that building and maintaining these critical resources has always been challenging. Many times it has been the heroic efforts of the Alice Eastwoods in our pantheon who risked everything to protect our heritage of plant knowledge. We owe it to these heroes, to ourselves, and to future generations to continue this direct tradition, to ensure a future in which plants and fungi continue not only to provide their fundamental needs for our existence, but also to delight our senses and imagination. And with that, I'll end. Thanks to the Linnean Society for giving me this opportunity to address you. And also thanks to the Linnean Society for their hospitality when I visited in October 2019, when I was finishing up the work on the book. Thank you.
Thank you so much, Barb. That was absolutely amazing. I mean, that was your book in less than an hour, but there's so much more in the book and so much more just like that. It's an absolutely, we've got lots of questions, and lots of questions coming in. Someone has asked, there was a case that and this is something you and I were talking about just before we started. Is there a case that loaned herbarium specimens can be destroyed in country quarantine or customs processes? And do you have any suggestions to prevent the same kinds of cases in the future?
Well, so the most recent case was in Australia, and indeed it was some specimens that had been collected in Australia, one of the very early expeditions, early French expeditions, which were being loaned for scientists in Australia. And exactly what happened isn't clear, but somehow the box ended up in a place for boxes that were not claimed, and nobody seemed to know what it was. And the customs destroyed it. The Australian, what happened then, the CHA, the Council of the Heads of Australian Herbaria, immediately engaged the customs people. And I doubt if, who can say whether or not customs office somewhere will destroy herbarium specimens again, but I'll bet you it won't be in Australia.
It won't be in Australia.
They clarified this and again, accidents can happen, but in this case, it seems to have been a lack of conformity to the Australian, very clear, as I've done it many times, Australia gives very specific instructions on how to deal with their specimens, how to label them and so forth. Seems as if either labels weren't attached or maybe fell off. And then there was just a problem, I think, it came down to, if I understand correctly, that the customs office did not have the up-to-date contact information for anyone at the herbarium to contact to say, do you know what this box might be, and so forth. So we have tried in the US very hard to have a closer relationship with our customs officials. And we will get, it's the sort of thing you have to keep doing. You will have a great relationship with someone, and then that person will move to another post and we start all over again. But that's a really important, you should always, every herbarium curator who receives shipments should know who their local customs person is, get to know that person. And if you can, invite them for a visit, invite them, some sort of thing where you can.
They love it. They think it's great.
Yeah.
Yeah. Well, thank you. Someone has asked, just wanted to know that the herbaria in the Ukraine and Belarus weren't on the map of Europe.
Yeah, I'm sorry about that. So it all goes back to so I'm the editor of Index Herbariorum, which is the index to the herbaria of the world. And for whatever reason, in the Index Herbariorum classification, those are not considered to be part of Europe. They're considered with Russia. I have actually moved away from any kind of classification of countries into larger units because it will never make everyone happy. And I agree that that's a particularly egregious method, but I'm afraid when that map was made, we used the old definition of Europe. So I apologize for that. There are many fine herbaria in Ukraine, very well cared for. There's actually an index to the Herbaria of Ukraine. So I do apologize for that omission.
Well, I thought it was probably something about the way the data were kept in the Index Herbariorum. Yeah. Someone has also asked a question which is much more a nomenclatural question, actually, but so you can have a go, Barb. He's asked, is there any way to check or ensure the presence of type specimens in the herbarium prior to the actual publication of the new species?
Oh, that is such a great question. And it just turns out that in the US, we've just had an incident where a new species of a rhododendron was collected in the Great Smoky National Park. And it was, published as a new species. The first problem was that they didn't actually have park permission to collect it. Second problem was it said right in the publication the isotype was at the New York Botanical Garden. So I immediately went into a tizzy because I thought we had inadvertently illegally accepted material without Park Service permission. But it turns out that no, this person was just intending one day to send an isotype to the New York Botanical Garden, but hadn't yet. So this points out a problem that in a publication people will often say, oh yeah, the isotypes are going to be distributed in various ways, but they may not be. We get requests all the time for specimens that are cited as being in our herbarium that aren't. Who knows what happens? The person made a different decision about where to deposit them. The name was changed. Maybe the paper was rejected. So we're requiring now in this in systematic botany that you have to have acknowledgement from the herbarium curator that they are indeed willing to accept that specimen. So if that happens, then we should be able to keep sort of a list, either on our database or somehow, of species that are supposed to be types that are supposed to be deposited but aren't yet. But you've really pointed out a serious problems in the way we do business, because a herbarium can be cited as a location and never know, you know.
Yeah.
And but
also it's really important to point out that there's nothing in the rules of naming a species that says that you have to have all of the isotypes distributed
right
before there's actually nothing in the rules that says you have to have the holotype distributed either. So yeah. You can imagine that you might describe a new species and you have seven specimens of it, and one is the holotype, which goes into your own institution, and then you distribute the rest. So kind of what's best practice in a way is to say holotype, where the holotype is, and then say isotypes will be distributed.
Right.
And then it avoids a problem. But that's like a really interesting question, because it's a conjunction of the rules and how people practice.
Right. Exactly.
And yeah. Okay, there's another question here, which is a really practical one. And he says, he normally used newspaper to press and dry the specimens in the past, but now I find difficulty in finding newspaper. I would like to ask if there's any other suggested materials that will be effective as the previous one. We always used to use just normal paper to press plants, and newspaper was a big innovation.
Yeah, we used to be able to get unprinted. Well, the thing is, use unprinted newspaper, but there's no unprinted newspaper. We're all going to be in it. The whole field could come to a grinding halt if there's no more newspaper, because that's what we've been using for years and years and years. I mean, you could always get free newspaper. I really think, though, there's a lot of paper that can work. I think the main reason we use newspaper because yesterday's newspaper was free. It was always available. No matter where you were in the world, you could always find old newspaper. However, I think there are many different, art shops, as someone suggested. The thing is, it's probably going to cost a bit more. Newspaper was such a great alternative because it was completely free. And you didn't have to take it with you. That's the other thing. You could find it wherever you were going. So we don't have a specific substitute, but I think we ought to be looking for some.
There's a couple of really specific questions, which maybe we can answer quite simply. Is somebody's asking if you can suggest any suitable method as a replacement for poisoning with mercuric chloride in alcohol.
Oh, okay. So we would never.
Freezing. Freezing is what we do.
Freezing is the only thing we're allowed to do anymore is freeze.
So mercuric chloride is absolutely poisonous, and nobody should be using it.
Nobody should be.
Really, really dangerous.
In fact, there's people who work in herbaria that used a lot of that have to severely limit the amount of time they can spend in the collection if they've been working there for years, because it's highly toxic. Freezing does work. Freezing in conjunction with a good integrated pest management system will control insects in your herbarium. You have to play around with how long you freeze them for. You have to have good protocols, but no, freezing works fine, but just requires a bit more organization.
Okay, Christopher Harper's asked, is most herbarium collections are of species or wild plants? Well, that's not quite, but are there any which contain cultivated plant specimens? I know ours does,
Sure.
and I know yours does.
Yeah, yeah. I mean,
Absolutely.
I think that would be the Royal Horticultural Society
Mhm.
would have an emphasis on that. So no, absolutely, horticultural plants are included in herbaria for sure. The only problem that we have is that those have to be segregated. They needed to be recognized as such if you're going to use these data for any kind of species distribution modeling. It can really throw things off if you have species occurring on a continent where they don't normally grow.
Yeah.
But no, absolutely. And in fact, had it not been for the collection of by the, I think it was the Arnold Arboretum, every year they collected from a plant right outside one of their main buildings, and they did it consistently right when the plant flowered every year. That was one of the first studies that showed that that you could use phenology to mimic climate change, and that the plants were flowering early over the course of a century. So horticultural plants have a lot of information to give us, although most herbaria that I know would not be as diligent as to collect from the same plant every year over.
That was a pretty exceptional thing that they did, wasn't it? It was absolutely amazing.
Yeah.
Let me just scroll down here. There's some, okay. Can you expand, someone's asked about, can you expand on the process of sending duplicate specimens from herbaria in countries of collections to other collections in the EU or the US?
Right. Well, I can describe our practices. So ever since I got to the garden when I got to the garden in the mid 1980s, early 1980s, we were engaged in a huge project in Brazil, Projeto Flora Amazonica. It was a huge binational collecting program. And that was one of the first that I know that said from the outset, all right, all duplicates are going to be split 50-50. Half will stay in Brazil, half can go out to specialists. Prior to that, I'm not sure. I mean, I know that was always best practice to leave the first set in the host country. But as far as I know, in my institution, that was the first project we entered into where that was required. So since you can collect duplicates of plants, the deal that we made with them, and we've made with many others, is half the duplicates stay in the country, but as an outside country, we will take responsibility for getting those plants identified by sending them out to specialists, getting determinations and reporting those determinations back, and then later distributing the duplicates. Now, different countries will make different arrangements. They're well within their rights to control how duplicates are distributed. I do think that our ability in botany to distribute duplicates is truly one of the great things. You can't do it with insects and other things like that. But this gives us such a great redundancy in the case of a herbarium being lost or destroyed. So I'm a huge supporter of duplicates. I will say they do complicate digitization and using data, because even if two specimens that are identical, it's amazing how many times the data have been recorded differently. And so sometimes telling that two specimens are duplicates from the same gathering is more challenging than it ought to be. But on the other hand, our ability to share data these ways is really a great thing in terms of maintaining this record of plant knowledge.
Yeah, it's absolutely great. Now, someone has asked about, there's a whole bunch of questions here, and I'm going to save one of them for the very end, which is one that came right at the beginning, but it's the one I'm going to ask at the, so Samantha, don't worry, I'm going to ask your question. It's just that I think it's the best one, and I want to save it to the end. Is Sarah Stewart has asked about, do you think that computational and big data approaches will play a stronger role in taxonomy, and how do you think this is potentially going to change research?
Well, I hope. I mean, what we've been adding up to with all of this incredible amount of work of digitization is to do exactly that, to be able to use these data in whole new ways for very broad scale analyses that we haven't been able to do before. Those will allow us to make broad predictions about floristic change, which then scientists can actually try to ground truth by going and seeing if these changes are happening. So I think increasingly big computation, approaches will provide hypotheses, which then we will go and test, you know. You will get a sense of which areas are most diverse, whether it's most diverse in terms of species or in evolutionary groups. You'll get those projections from these large from these large data assemblies, and then you can go to those spots and look. So I think it'll be kind of a reversal. We used to, you know, go collect and then see what comes of that, see what comes of the collecting. Now I think we'll look at the data and then we'll see where the collecting's needed. I think these large assemblies will really drive field work in the future. And what's great about that is we'll be able to be a lot more targeted and have a lot more time for making more of these extended types of specimens. So collecting will never end. I think we'll get smarter about it because we will have, you know, on your phone, essentially now in the field, you can have the contents. You can have 80 million herbarium specimen records at your disposal while you're standing in a rainforest, assuming you have coverage, but you know, we're getting there. So, you know, it will inform how we continue to survey, and again, how we plan conservation measures and restoration projects and so forth.
Great. There's one more very practical question about techniques to preserve the color of petals.
Yeah.
And in my experience, it's basically, it depends on the plant.
It does. It depends.
Just
So
depends on the plant. We have specimens in our herbarium that were collected by Linnaeus that are still bright blue.
Oh yeah, Linnaeus's delphinium in his herbarium is just as blue as it can be. So we often put out on display, we'll put out specimens from the Western United States, from an arid region where the colors and the petals are vibrant and beautiful. And then we'll put out a tropical rainforest tree where they're brown and muddy. And a lot of it is water content, right? And plants from drier areas, it seems as though they're able to maintain their color better. But there really isn't any specific technique. Keeping them out of the sunlight will help a little bit, but they're going to fade, and that's just the way it goes. That's
why labeling a collection is so important, to put the colors on, because otherwise you won't know. Right. They won't know. That's why labeling is so important.
Sandy,
so, Carl, what?
I have a question from YouTube Live. So we're live streaming. I'm just going to ask it, Barbara.
Sure.
They want to know, how does Africa fare in herbaria practice? And are there any active herbaria in Africa? And did your study extend to them?
Yes, I was afraid I would run out of time. I did have an African example in there, and I do in the book. I focused on South Africa because it has a long herbarium tradition, but there are, I don't know. I think there's several hundred herbaria in Africa, and I believe they have total between 5 and 7 million specimens. The largest herbaria are in South Africa, followed by Kenya, which also has very large herbaria, and then also Egypt and Ethiopia. So yes, Africa does have quite a few herbaria, has quite a few developing, herbarium developing countries that are still in the process of making that kind of a primary assembly for their own use of their specimens. And I know that there are several projects underway to kind of digitize and unite African herbaria. So yeah, I apologize for not including Africa in this, but indeed they do have many important herbaria.
The book, there's a very long and there's a great chapter, a whole section in the book about African herbaria, and it's a very strong tradition. And as far as I know, when I did a monograph of African plants, I sent a copy of the monograph to every single national herbarium, and there was a national herbarium in every single African country. Yeah. So Carl Group has asked us that you mentioned new technology, genes, and traits. Mm-hmm. What would you be most excited to be able to discover about a herbarium specimen, from a herbarium specimen?
That's a good question.
It's a hard one.
Yeah. I mean, one single fact I would have a hard time saying, but it seems like what we all really want to know is why a plant grows where it does. You know, what are the traits that are allowing it to live in this habitat and not that habitat? And if we could find the genes that were responsible for allowing that plant to take advantage of fungi in the soil through mycorrhizal associations that allow it to obtain more nutrients, or whether it's something about the way the leaves are structured, which are allowing it to maximize the sunlight and decrease the water loss. So, you know, it's connecting the genetic traits to actually why plants are able to grow where they grow. That information could save us, could save could save humanity if we can figure that out, you know, because then we can grow crops to fit a changing climate.
Yeah. No, it's there's a lot to discover, and it's almost it's kind of almost the assembly of all of that knowledge, which kind of makes it special.
Right.
Okay, so someone has asked what I think is a really great question, is as a layperson, is there anything I can do to make a positive contribution to Herbaria? Yes.
I also talk about this in the book at the end. Yes, indeed. Most herbaria would not be able to do what they do without volunteer help. Volunteers are incredibly important. In many cases, volunteers are primarily responsible for gluing the plants to specimens, for mounting the plants. It's very common. But there are other ways. If you don't live near a herbarium, if you do live near a herbarium, then by all means contact them. And I'll bet you, I would be very surprised if you were not encouraged to volunteer to help in some way. But even if you don't, there are many online ways that you can help. There are herbaria all around the world who have digitized all of these specimens, but what they haven't done is transcribe all of the data from the specimen label, what the plant is, where it grows, who collected it, when, there are a number of online platforms that you can use to do that. In Britain, there's Herbaria at Home, which is extremely popular and very sophisticated users in that. The French have Les Herbaria, which is for transcribing French. Again, fair level of sophistication. In the US, and in Australia, there's we use something called Digivol, which is run by the Australian National Museum, which is a wonderful platform that anyone can join and transcribe from a variety of projects. We also have something called Notes from Nature, which also provides that opportunity. So there's many opportunities. And this is the sort of thing you can just do for an hour, you know, at night or something. And it makes a huge difference to us, a huge difference. I don't know worldwide what the contribution is, but I know in my institution, volunteers contribute often more than 100,000 specimens a year. So there are many ways you can volunteer and help herbaria. So please do so.
Yeah, I would echo that. And I think the great thing about if you're not near a herbarium, transcribing online means that you don't have to transcribe the specimens from your area. You could, if you're interested in Australia, you can go onto one of those platforms and look at things from Australia. It's a wonderful way to travel the world without leaving your bedroom.
Absolutely.
It's a really great way to do that. It's been fantastic during COVID time.
Yeah.
So the very last question, there's one more that's come in about mushrooms. About mushrooms very prone to decaying. So any specific tips to preserve them other than drying and freezing?
Well, we dry them. Mushrooms are tricky though. They have to be dried almost immediately after collection. They really begin to degrade almost immediately. So in the field, they have to be dried well with forced air, but usually at a temperature that's lower than what is used for flowering plants. They cook. You really need a low but constant heat supply. Many an unhappy mycologist has put their specimens on top of the plant press in a tropical collecting expedition and found that they were, you know, suitable for putting on a hamburger, but not for a specimen. So you have to dry them, and then you have to keep them dry. Once they're dry, they become very brittle. So normally it involves quick drying, moving them to plastic bags with silica gel, patting them very carefully, and then threatening the life of anyone who would drop your box of specimens before it gets safely to its destination.
Absolutely. Yeah. Okay, so this is the last couple of questions, and I'm going to pull these two together. But
okay.
Samantha's asked a question very early on that I thought was one I had to leave to the end. That what does the future look like for herbaria, and what kinds of constraints are there to compiling herbaria in the future?
Well, I am an optimist, And I think the future of herbaria is bright. I think that there have been a lot of news stories, sort of doom and gloom, about the decline in collections. Some of them were actually based on rather faulty information. As an editor of Index Herbariorum, I know exactly how many herbaria are added each year, and generally it's about 60 per year. 60, they're not in Europe or in North America, but they're in other parts of the world where there is significant diversity still to be discovered. So I don't believe herbaria are on their way out. There are things that are worrisome. We have some very large herbaria that have hardly anyone taking care of them. That's a huge problem. But I think the increased digitization of data and the use of these data point to herbaria continuing to be important. It takes a lot of work, though. I think, I like to say to my staff and anyone who will listen that as important as, filing the new specimens and gluing them to paper is every day looking for a way to keep what we do relevant to science, to education, to human well-being. You have to work hard at this to stay relevant. And so the constraints, the problems are funding always. Collections seem as though they might be able to go quite a while without a lot of care. After all, they're just dead plants in a case, right? But they need a lot of care. There needs to be a lot of education. People are woefully ignorant about museum collections in general. How many times I've heard somebody talk about dusty old museums as if nobody uses them and nobody collects them. It's bad press that we have to fight against all the time. The problem isn't that we don't have great herbaria. It isn't that we don't have great uses for the data. What we haven't done a particularly good job of is working every day to convince people about why this is a critical resource. So that's the constraint. It's our own creativity, really, and making sure that everyone appreciates the value of this resource. As scientific resources go, herbaria are not particularly expensive, but they are crucial, and they will degrade if they're not cared for.
I always liken them to the kind of the same kind of infrastructure as big physics uses, which is very expensive, colliding superconductors and Fermi Lab. And those CERN, those really big infrastructures. It's only that herbaria have been built up over many, many years. Someone's asked a very specific question about how to find out about the Edgeworth family's contribution to botany and Edgeworthia. And I think the answer to that one is that there are some really wonderful indices of botanists. One of the most complete ones is at the Harvard University Herbaria, which I put in the chat. But
great.
There are lots of ways to find out about people's contribution to botany. Online, and there are and Edgeworth is a particularly interesting one. Edgeworth was an interesting botanist.
And actually, never underestimate the power of Wikipedia. There are so many Wikidatans who are constantly adding names of collectors to that resource. It's amazing.
There's a very wonderful. I'll put it in the chat to all the attendees. There's a wonderful website called bionomia.net. Which is I'll attempt to type it in here, but it's a place where you can look up where people have collected and just really look at individual people's contribution to botany and to generally to natural history. And it's a wonderful website, and you can volunteer you can match up people, you can look for collections. It's one of those wonderful places that, again, you can help herbaria by doing this from home.
Yep.
So Barb, I just want to thank you so much for an amazing talk and for answering so many of the questions that people have put to you. And a lot of them were very specific, but a lot of them are actually things that people are thinking about. And it means there's a real interest in herbaria from all around the world. And we've had hundreds, more than 100, we had almost 200 people here tonight. And so I think that's really great. And it's testament to how interesting not only the topic is in general, but how interesting you made it. So thank you so much, Barb. And thank you everyone for coming to our Linnean Society lecture series. And please do come to our next one. And we look forward to seeing you online again very soon. So thank you so much, Barb, for an absolutely wonderful talk. And I look forward to seeing you in person again soon.
I do too. The sooner the better.
The sooner the better. Absolutely.